Welcome to Easy Driver, the most reliable source of automotive information on YouTube. Maximizing valve performance, understanding and addressing defective valve action. Valve action is a critical component in various mechanical and industrial systems. When a valve malfunctions, it can lead to severe operational issues, safety concerns, and production delays. In this video, we will delve into the common causes of defective valve action, the potential consequences, and the best practices for identifying and addressing these issues effectively. Please give us a like, share, comment, or better yet, please subscribe to our channel so you can get more informative videos like this. Whether you're a maintenance technician, engineer, or simply interested in understanding the importance of proper valve function, this post will provide valuable insights to help you navigate the complexities of valve action and maintenance. Understanding valve action. What is a valve? A valve is a mechanical device that regulates the flow of fluids, such as gases, liquids, or slurries, by opening, closing, or partially obstructing various passageways. It controls the pressure, temperature, and flow rate within a system, thus ensuring the smooth and efficient operation of machinery and equipment. Importance of valve action. Valve action is crucial in various industries, including oil and gas, manufacturing, and petrochemicals. It ensures the precise control of fluid flow, pressure, and temperature, leading to enhanced process efficiency and safety. Proper valve action is essential for preventing leaks, blockages, and hazardous conditions, ultimately contributing to the overall reliability and performance of the systems in which they are employed. Common defects in valve action. Leakage. Valve leakage is a common defect that can lead to inefficiency and potential hazards within a system. This can occur due to improper sealing, wear and tear, or damage to the valve components. Leakage can result in loss of pressure and flow control, leading to increased energy consumption and potential safety risks. Regular inspection and maintenance are essential to identify and address leakage issues before they escalate. Sticking. Sticking valves can disrupt the smooth operation of a system, causing inconsistent flow or complete blockages. This defect often arises from the accumulation of debris, corrosion, or inadequate lubrication within the valve mechanism. Sticking valves can hamper system performance, leading to operational inefficiencies and potential equipment damage. Implementing proper cleaning and lubrication practices can help prevent and resolve sticking valve issues. Noisy operation. Noisy valve operation can be indicative of underlying defects such as cavitation, vibration, or internal component damage. Excessive noise during valve action can disrupt the work environment, signify potential safety concerns, and hint at inefficiencies within the system. Identifying the root cause of noisy valve operation is crucial for ensuring smooth and reliable system functionality. Implementing proper maintenance and addressing any underlying issues promptly can mitigate the impact of noisy valve operation and uphold overall system performance. By understanding and addressing these common defects in valve action, operators can uphold the operational integrity and efficiency of their systems, minimizing downtimes and ensuring optimal performance. Causes of defective valve action. Wear and tear. Valves in a system are subject to wear and tear over time due to constant use and exposure to high pressure and temperature. The constant movement of the valve components can lead to erosion or corrosion, causing leaks or malfunctions in the valve's action. This wear and tear can result in the valve failing to open or close properly, leading to defective valve action. Improper maintenance. Failure to conduct regular maintenance on valves can lead to defective valve action. When valves are not properly lubricated, cleaned, or inspected, it can result in the buildup of debris and corrosion, hindering the smooth operation of the valve. Neglecting maintenance schedules can also lead to the deterioration of valve components, impacting their functionality and causing defective valve action. Contaminants. Contaminants such as dirt, rust, or foreign particles can infiltrate the valve system, affecting the performance of the valve. These contaminants can cause blockages, corrosion, or damage to the valve components, leading to improper sealing and functionality. The presence of contaminants can disrupt the smooth operation of the valve, resulting in defective valve action. The causes of defective valve action, including wear and tear, improper maintenance, and contaminants, can significantly impact the functionality of valves in a system. Understanding these factors is crucial in addressing and preventing issues related to defective valve action. Consequences of defective valve action: reduced efficiency. When a valve is defective, it can lead to reduced efficiency in the system. A faulty valve may fail to regulate the flow of fluid or gas effectively, resulting in fluctuations in pressure and flow rates. This inefficiency can lead to increased energy consumption and decreased overall performance of the system. As a consequence, it may result in higher operational costs and reduced productivity, impacting the bottom line of businesses relying on these systems. Safety hazards. Defective valve action poses significant safety hazards in various industrial and commercial settings. Malfunctioning valves can lead to leaks, spills, or uncontrolled releases of hazardous materials, putting workers and the environment at risk. Such incidents can result in chemical exposure, fire, explosion, and other life-threatening situations. The potential dangers associated with faulty valves underscore the critical importance of ensuring proper maintenance and regular inspection of these essential components across different industries. Troubleshooting defective valve action. When dealing with defective valve action, it's crucial to conduct a thorough troubleshooting process to identify the root cause of the issue. Troubleshooting defective valve action involves visual inspection, testing for leakage, and identifying sticking valves. Visual inspection. Initiate the troubleshooting process by conducting a visual inspection of the valve. Look for any signs of physical damage, corrosion, or irregularities on the valve body, stem, or actuator. Check for any visible leaks or unusual fluid patterns around the valve. Additionally, inspect the surrounding area for any indicators of potential issues, such as excessive vibration or unusual sounds during operation. Testing for leakage. Testing for leakage is a critical step in identifying defective valve action. Utilize appropriate testing equipment to measure and detect any leaks in the valve system. Conduct a pressure test to assess the integrity of the valve and identify any potential sources of leakage. Pay close attention to the valve packing and seals, as they are common areas where leaks may occur. Document and analyze the results of the leakage test to determine the extent of the issue. Identifying sticking valves. Sticking valves can significantly impact the performance of the system. To identify sticking valves, observe the movement of the valve during operation. Look for any irregularities or hesitations in the valve's motion. Utilize appropriate diagnostic tools to measure the actuator's response and assess the valve's functionality. Additionally, consider the environmental conditions that the valve is subjected to, as temperature variations and contaminants can contribute to valve sticking. By systematically conducting visual inspections, testing for leakage, and identifying sticking valves, you can effectively troubleshoot defective valve action and take necessary corrective measures to ensure optimal system performance. Preventing defective valve action. Regular maintenance, proper installation, and the use of quality valves are essential in preventing defective valve action. Regular maintenance. Regular maintenance is crucial in ensuring that valves function properly and do not develop defects over time. This includes periodic checks for leaks, corrosion, and wear and tear. Lubricating moving parts and replacing worn-out components are also part of regular maintenance to prevent defective valve action. Proper installation. Proper installation of valves is paramount to prevent defects. This includes ensuring that valves are installed according to manufacturer specifications and using the right tools and techniques. Using quality valves. Using high-quality valves from reputable manufacturers is a proactive measure in preventing defective valve action. Quality valves are designed and built to withstand varying conditions and are less prone to defects compared to low-quality alternatives. Investing in quality valves can save time and money by reducing the likelihood of defective valve action. Incorporating these preventive measures can significantly reduce the risk of defective valve action, ensuring the efficient and reliable operation of industrial systems. In summary, addressing a defective valve action is crucial for maintaining the efficiency and safety of the system. By promptly identifying and rectifying any issues with the valve, you can prevent potential malfunctions that could lead to costly downtime or safety hazards. Regular maintenance and proactive monitoring are essential to ensuring that the valve functions as intended, and seeking professional assistance for any signs of the malfunction is highly recommended. Taking these proactive measures will not only extend the lifespan of the valve, but also contribute to the overall smooth operation of the system. Please don't forget to comment, like, share and subscribe for more automotive information like this. Thank you for watching.